Okay, so today we are going to do section 2.7. Sorry, that made a loud noise. I'm trying to adjust the microphone. Okay. So 2.7 is on inverse functions. So, things you need to know about inverse functions. First of all, the definition of inverses is that if f and g are inverses, then f of g of x and g of f of x are both going to work out to be x. So they're inverse functions. That means that they have all of the exact opposite operations, basically. So if you plug one into the other, things should all cancel out, is what that first statement is saying. The next three bullets are just saying that we use f inverse, this little f to the -1, to mean the inverse of the function f. And then we can do f of f inverse of x would be x, and then f inverse of f of x would also be x. So sometimes we call them f and g, and we're trying to decide are they inverses. Once we know for sure they're inverses, we tend to use that inverse notation. And then the domain of f is the range of f inverse, and vice versa. So the domain of f inverse is the range of f. So if you'll remember, when you learned this in Algebra 2, we learned that inverses are just like switch x and y. Is one way of finding it. That's how you find inverses, is switching x and y. So that's why domain and range like flip-flop, because domain is x and range is y. Alright, so the first thing is we just want to be able to show that they're inverses. There will be a question like this on your test, which is Friday, by the way. We're just going to plug g into f, show legal math and some steps where things cancel out and we just get f, and then plug f into g and do the same. So, to show that two functions are inverses, we have to find f of g, and then we have to find g of f. And let's just show with good math that we're going to cancel out and just have an x left. Alright, so to do f of g, we're going to take the g function and plug it into the f function. So our f function is 4 times something minus 7. Well, the g function is what we put in the parentheses, and it's x plus 7 over 4. Alright, so you cannot go straight from here and just say it equals x, yay, I'm done. You need to show that things are happening. So, these 4's cancel out, and I have x plus 7 minus 7, and then plus 7 minus 7 makes 0, and so I just have x. Alright, so on to g of f. So the g function says something plus 7 over 4. Alright, so the something is going to be the whole f of x function, so 4x minus 7. Alright, so again, canceling things out in the correct order is important. Minus 7 plus 7 makes 0. So, I'm struggling hard. Sorry that those things keep popping up. I can't make my arrow down there hit the right color. So then we, see, I still didn't, it's okay. So we have 4x over 4. And then we know that the 4's cancel, and I just have x. So once you have both of them are x, then you can just say woohoo, I'm done. Alright. Okay. So, we really just said all of this. So f to the -1 means f inverse, and the two functions undo each other. That's what makes them inverses. We just showed that in that last example. Alright, so if I want to find the inverse of a function, we have these steps to follow. Alright, pause if you need to write them down, because I'm just going to read through them fast and do an example. Alright, so first of all, you change f of x to y. Then you switch x and y. Then you solve for y. And then you replace the y with f inverse. I do not need you to check. If your directions on your homework tell you to check, you don't have to do it. There are going to be ones that tell you to prove. That's enough practice of that. You do not have to do that last step. We'll assume that we do correct math. All right, so if I want to find the inverse, let's see if I can put all of these on the screen so you can see them all. So we'll do A right here. All right, so we're going to, I'm going to do some of it over here. So we got y equals 2x plus 7 if we just do that first step and replace it with the f of x with y. All right, then I'm going to switch x and y. So I'm going to call it x is equal to 2y plus 7. Now we want to get y by itself. So we're going to subtract 7. And we're going to divide by 2. And then put your function notation back. So this would be f inverse of x is equal to x minus 7 over 2. All right. So for B, if we write this as y equals 4x to the third minus 1, then when we switch x and y, it would be x is equal to 4y to the third minus 1. So then we're going to add 1, divide by 4. All right, so now the inverse of 2 the third is cube root. So I'm going to take the cube root of this side and the cube root of this side. And I'm done. We just need to write it with that inverse notation. Let me slide this up just a little. So I'll write it as f inverse of x is equal to the cube root of x plus 4 over 4. All right, I can't remember if this is handled in this. I'm going to say it now and I may repeat myself later. If this is a square root or a fourth root that you take, remember you got to put the plus or minus. Usually if that situation is there, there's going to be like a domain restriction, because if you take something that's squared or to the fourth, the ends are both going to point up. So if I try to switch x and y and reflect over the line y equals x, I'm going to get something that looks like this, which is not a function. So if we have something that is a square or a 4 or a 6, any even exponent, they're going to have to restrict the domain if they want you to find the inverse, because the inverse is not going to be a function if we don't restrict the domain and say I just want the left side or the right side. So if you see something with a little statement behind it that says if x is less than 1, then that's what that statement is meaning, is we're restricting the domain to make this thing work out. All right, so on to part C. All right, so again, we're going to call this y equals 3 over x minus 1. Then we're going to switch x and y. Then we've got to get y by itself, so we're going to add the 1. All right, then we're going to multiply by the y, and then we'll divide the x plus 1. Whoa. Let's solve that back up. Okay, so we will multiply by y. So it looks like this. I'm not going to distribute it because I need all of that junk to go away. So we're just going to multiply it over there and then divide x plus 1 back, or not back because it wasn't there in the first place. We're going to divide x plus 1 over to the other side. And then we can put our inverse notation, and we are done. Okay, next. All right, so we have discussed that we know we have a function if it passes the vertical line test. So this passes the vertical line test. Let me see if I can get, no, really good. It won't let me draw one. So, okay. hang tight. Okay, so pretend like that's nice and pretty and vertical. Alright, so if I take this, if it'll let me, if I move that vertical line across my picture, it only touches one time, so that's a function. Same thing happens over here. If they gave me a picture that looked like, we'll say, not that, give me a picture that looked like this. If I tried the vertical line test, no, really. There we go. Then it doesn't pass the vertical line test because I've got points lined up vertically on my graph. Alright, so what we are going to do to check if it's an inverse is a function is we're going to do a horizontal line test. Alright, so if we are saying that this guy is our function, if we're going to do the inverse, you switch x and y, which I think is a couple of examples later. So just real fast, because I'm not standing in front of you moving my arms, which is how I would normally teach this. If I take this point, and this point, and I try to reflect them, switch x and y, then this point's going to stay the same. We'll say he's at 1, 1. 0, 0 will stay, but this point that's at negative 1, 1 is going to now be at positive 1, negative 1. So if I take negative 1, 1, and I switch the x and y, it becomes 1, negative 1. So I would have this picture, and it's not going to pass a vertical line test. But instead of having to do that every time, what we can do is that we can do a horizontal line test. So, I don't know why I keep trying to do that. No, it won't work. Alright, so if I take a horizontal line and put it across a function and move up and down, this is going to pass a horizontal line test. That means that this guy's inverse is a function. If we take a horizontal line and try to do a horizontal line test, oh my goodness. Okay, if we try to do the horizontal line test here, we see that we fail. So this one is not a function. Its inverse is not a function. Okay. Alright, so you try these real fast. Which of the following graphs represents a function that has an inverse, that is also a function? Alright, so if you think about taking this and reflecting it over the line y equals x, then he would look something like this, right? But without having to stop and think about all of that, we can just use that horizontal line test. So if I take a horizontal line and I run it across my picture, it's only going to cross once. So this guy has an inverse that is a function. Alright, if I take my line and I test this one, then his inverse is not a function. Alright. Okay, so a one-to-one function. So a function, just the definition of a function is that every x has only one y. For it to be one-to-one, that works the other way. So every x has only one y, but every y also has only one x. So it's got to pass a vertical and a horizontal line test. Alright, and so then these last two bullets is what I told you is going to be coming up in a minute, but I spoke about it a minute ago. So the graph of f inverse is a reflection of the graph of f about the line y equals x. And to get the new picture, you just switch the X and the Y of the points on one, and you get the points on the other. All right, so they tell us that F consists of two line segments, one from -2, -2 to -1, 0. So we have that, and then we go from -1, 0 to 1, 2. Then we have that. All right, so we graphed F, use it to graph the inverse of F. All right, so we have points at -2, -2, at -1, 0, and at 1, 2. All right, so if we switch X and Y, we're going to still have a point at -2, 2. -2, -2, I'm sorry. But this point that was at -1, 0 is going to be at 0, -1. And the point that was at 1, 2 is going to be at 2, 1. So it would look like this. All right, so the red function is obviously red and not orange. The red function, there we go, is F. The blue function is the inverse of F. And if we think about where the line y equals x would be located and what our picture looks like, you see that it is a reflection over y equals x. All right, so next, here's one I told you it was going to be coming up later, and I was just repeating myself. So here's one that's x squared. Well, if I try to do x squared plus 1, first of all, remember your parent functions. X squared is a parabola, plus 1 swings it up so that it's landing here. So this is y equals x squared. If I tried to reflect it, I would get something that looks like this, which is not a function. This passes a vertical line test, but not a horizontal line test. So it's not a one-to-one function, which means that its inverse is not going to be a function. So they are restricting it, saying that we only want numbers 0 and bigger for x's, which means that this point is good, all of these points are good, but we've got to get rid of all of those. So they restricted the domain of this quadratic so that it would be a one-to-one function, and its inverse would be a function also. All right, so that is my f function. So this is f. So to graph its inverse, we're going to take these points. Keep changing my color too soon. All right, so this point is at 0, 1. This point is at 1, 2. We could do more, but that's enough to get the idea. All right, so 0, 1 is going to become 1, 0. And 1, 2 is going to become 2, 1. And it's going to make like the reflection of that, so it's going to go something like this, which makes it the reflection over y equals x. You don't have to draw this y equals x in there. I'm just doing it to make the point. All right. Okay, so that's it. Let me look up the assignment for you, and I'll type it in. Hang on just a second. Okay, so the assignment is on page, sorry y'all, I thought I could multitask, but obviously that's not happening. Okay, the assignment is on page 321, 322. We're doing 5 through 25 multiples of 5, and then 29 through 38 all. And on the ones that fall from, I guess, what is it, 15, 20, and 25. You're only doing part A. I don't need you to verify on part B, because that's what you're spending the first couple of examples doing, so. Yeah. I may change my mind on what the assignment is. So right now that's the assignment, but make sure you check what I actually typed into Google Classroom, because it may change. All right, we have a test on Friday, so make sure that if you have questions, you're asking them.